Hi, my name is Hoonshin Jung from the Water Institute of the Gulf. The title of my presentation is Modeling the Change in Nutrients and Phytoplankton Dynamics from Large-Scale Coastal Restoration in Louisiana, USA. Because of high rates of wetland loss in coastal Louisiana, mid-Mediterranean sediment diversion is proposed to create new wetlands and sustain existing wetland areas in Mediterranean basin. It will introduce a lot of sediment and nutrient-rich freshwater into the basin from the Mississippi River. Eventually, it will change the physical and ecological environments in the receiving basin. The goal of this study is to investigate potential impacts on phytoplankton dynamics due to the large-scale restoration project. Specialists will focus on three things: change in the nutrient environment, impact of suspended sediments on phytoplankton, and change in phytoplankton composition. There are 7 freshwater inflows into the basin. Figure shows annual mean freshwater inflows at each location from 2009 to 2011. The blue and red box represent the total freshwater inflows for no diversion and with diversion cases. Delft 3D water quality model was used. The model was calibrated and validated for year 2009 to 2011 using existing water quality data in Mediterranean basin. The figure shows one of the calibration and validation results at a station in the basin. Annual total nitrogen and phosphorus loading into the Mediterranean basin were calculated and compared with other systems. The solid line represents the Redfield ratio of total nitrogen and phosphorus input in mass. The blue dots are from the Mediterranean basin. The current total nitrogen and phosphorus loading is similar to Buttermilk Bay. When freshwater input increases due to the sediment diversion, total nitrogen and phosphorus loading become close to the Potomac River. Regardless of the inflow conditions in the Mediterranean basin, total nitrogen and phosphorus ratio are well above the Redfield ratio of phytoplankton. These figures show the spatial distribution of suspended sediments and the chlorophyll concentration in April for no diversion and with diversion cases. Blue arrows indicate the location of the mid-Mediterranean sediment diversion. In case of no diversion, high chlorophyll concentrations were observed in the lower part of the eastern basin. However, freshwater input from the Mississippi River into the basin increased the sediment and nutrient concentration in the basin. It changed the distribution of phytoplankton in the basin. Especially, no phytoplankton was observed near the diversions due to the light limitation. Instead, high chlorophyll concentration were observed in nutrient-limited area far from the diversion. This figure shows the spatial distribution of water temperature and the dominant phytoplankton taxa in April for no diversion and with diversion cases. In the right figure, purple color represents anabaena, cyan color represents microcystis, and red color represents freshwater diatom. In case of no diversion, the dominant phytoplankton in the basin was anabaena and microcystis. But with diversion conditions, dominant phytoplankton becomes freshwater diatom. It is caused by the cold freshwater inflows from the Mississippi River. In these studies, we found, first, freshwater from the Mississippi River changed the nutrient environment of the basin. The second, suspended sediment limited the spatial distribution of the phytoplankton by light availability. Finally, cold freshwater input can change the dominant phytoplankton taxa in the basin. Thank you.